Hi, my name is Mario, and today I will be presenting a project on predicting the electrical energy output of a combined cycle power plant. This presentation will cover the model selection and evaluation process. The objective of this project is to predict the net hourly electrical energy output, or PE, of a combined cycle power plant. We have dataset containing 9,568 hourly average ambient environmental readings. The features in this dataset include temperature, ambient pressure, relative humidity, and exhaust vacuum. The target variable we want to predict is the net hourly electrical energy output in megawatts. Based on the correlation matrix, all features had a significant correlation to the target variable. Based on these results, all 4 features were selected for the modeling process. Since we are predicting a continuous variable, we can apply a regression analysis. To evaluate our model performance, we will use the root mean square error, which measures the average magnitude of the errors between predicted and actual values. I use Python for this project because it allows for efficient data manipulation, model building, and evaluation. To ensure our model performance, we first split our dataset into a training set and a test set using a 80-20 split. The training set was used to train the models, and the test set was used to evaluate the final model's performance. For comparing different models, we use 5-fold cross-validation on the training set. This involves splitting the training data into 5 subsets, training the model on 4 subsets, and validating on the 5th subset. This process is repeated 5 times, which each subset uses exactly once as the validation data. The cross-validation scores are the average to get a more robust estimate of the model performance. We consider several algorithms for this regression task, including multiple linear regression, decision tree regression, random forest regressor, gradient boosting regressor, and support vector regressor. For this project, we selected multiple linear regression and random forest regressions. To compare the models, we use Python code to perform 5-fold cross-validation and measure performance using the mean square error, and calculated the root mean square error from the MSE, and here are the results. Based on these results, we select the random forest regressor as the best model because he had the lowest mean MSE and RMSE. Now, let's talk about the random forest model. Random forest is an ensemble learning method that combines multiple decision trees to improve accuracy and robustness. It uses bootstrap sampling to create multiple subsets of the training data and trains a decision tree on each subset. At each split in the tree, a random subset of features is considered, which reduces the correlation between trees. The final prediction is obtained by averaging the prediction of all individual trees. One of the key advantages of random forest is high accuracy and robustness. It also less sensitive to outliers and provides an indication of future importance. I use Python to evaluate the random forest model, calculating the root mean square error, which achieved 3.24 megawatts on the test set. This means that, on average, our model predictions are off by 324 megawatts, which indicates good predictability and accuracy of the task. Let's recap the key point of this project. We successfully identified the task as a regression problem, focusing on predicting the electrical energy output using 4 key features: temperature, ambient pressure, relative humidity, and exhaust vacuum. We consider algorithm and I compared the performance of different models using 5-fold cross-validation to ensure robust performance evaluation. We specifically focus on multiple linear regression and random forest regressor. For model evaluation, we set root mean square error and calculated for each model using cross-validation, and ultimately selected the random forest regressor, which achieved an RMC of 3.24 megawatt on the test set. Lastly, we communicate performance for our model, explaining the random forest model advantages. We presented a comparison table that included mean MSE, standard deviation, and RMSE for all the model evaluating, demonstrating the superior performance of the random forest regressor. Thank you for your attention.